next, let's graph the following parabola. And I want to make sure we state the vertex, the domain, the range, the line of symmetry, and whether or not it has a maximum or a minimum. So whether or not that vertex is the maximum or the minimum. And we can tell that by looking at whether our A value is positive or negative. If our A is positive, our graph opens upward and it has a minimum. If our A is negative, our graph opens downward and it has a maximum. So as our A here is negative, the point we have is a maximum. So that maximum point is going to be the vertex. We find the vertex HK, where H is negative B over 2A, and K is F of H. And we talked about this in the last video. So I'm going to go ahead and say that A is negative 3, B is negative 2, C is 1. So H is a negative 2, that's my B, over 2 times negative 3. That gives me a positive 2 over negative 6, so negative 1/3 is my H. I'm then going to go ahead and substitute that into my function. So I have F of H is F of negative 1/3 is negative 3 times negative 1/3 squared minus 2 times negative 1/3 plus 1. So that would give me negative 3, negative 1/3 squared is 1/9, negative 3/9 plus 2/3 plus 1. Let's write everything with the same denominator, negative 1/3 plus 2/3 plus 3/3. That gives me 4/3, which is about 1.3, continuing. So my vertex is when x is negative 1/3, y is 4/3. So when x is negative 1/3, y is 4/3, which is just a little bit more than 1, so we're right about here. And I know this is going to open down. I can then find the y-intercept. If I set my function equal to 0, if we let x equals 0, that's how we find the y-intercept. So f of 0 is negative 3 times 0 squared minus 2x, which is 2 times 0, plus 1, which is just going to give me 1. So my y-intercept is when x is 0, y is 1. I can then go ahead and find my x-intercepts. That would be by setting my entire function equal to 0. So let me go ahead and clear myself a little bit of room. Yes, this is more than I asked us to list, but I want to go ahead and solve for everything. And in order to graph a parabola, we need 3 points anyway, so why not? So in order to find my x-intercepts, I let y equal 0. Well, y is f of x. So 0 is negative 3x squared minus 2x plus 1. And this is a quadratic function, and we know how to solve these. We could use the quadratic function. We could complete the square, which no one wants to do. I don't mind it. And then we could find the factors of a, c that add up to b. Well, in this case, a is negative 3 and c is 1. So ac is negative 3. What are some factors of negative 3 that add up to negative 2? How about negative 3 times 1? So I'm going to use that to pull my middle term apart because my leading constant a isn't 1. So I have 0 is negative 3x squared minus 3x plus x plus 1. And then we factor by grouping. The greatest common factor of negative 3x squared and negative 3x is a negative 3x. The greatest common factor of x plus 1, of x and 1, is going to be 1. Then I collect the greatest common factor, so I have 0 is a negative 3x plus 1 times x plus 1, and I've set each of those equal to 0. So x plus 1 is 0, so x is negative 1. That means when our x-intercepts is when x is negative 1 and y is 0. Our other x-intercept is negative 3x plus 1 is 0, and we solve for x. I subtract 1 from both sides. Negative 3x is negative 1, so x is 1/3. So when x is 1/3, y is 0. So we found our x-intercepts. So this is our parabola. What a beaut. Its maximum is our vertex. The domain goes from negative infinity to positive infinity. The range goes from negative infinity all the way down there to positive 4/3, and that 4/3 is included. And then the line of symmetry is when x equals negative 1/3. So we found everything we could figure out about this parabola essentially, right? We got our vertex. That vertex is a maximum. We found our y-intercepts. We found our x-intercepts, the domain, range, and axis of symmetry.